Hi everyone, Architecture and Operating System. We are in week 2, and in this week I'm going to introduce binary arithmetic with negative numbers. By this point, I expect everyone to be confident with the decimal and binary numbers and the operation with binary arithmetic, which are addition, subtraction, division, and multiplication. But today we are going to talk about the negative numbers and why do we need to learn them and why that's important for the computer. Look guys, if we want to subtract two numbers in arithmetic, what we do, we say take away 2 from 5, which is 3. But computer doesn't do that in this way. What it does, it converts this subtraction to the addition and then make the second number negative. Same thing, 5 minus 2 is 5 plus minus 2. By making the second number negative, so actually what it does, only add the numbers. So same answer. So literally what happens, the computer tries to make, instead of doing subtraction, it tries to do addition. Why that happens? Look guys, if you want to subtract these two numbers in computer, we need a specific components and hardware to do that. And again, and circuit. And the same thing for the addition. If you want to add two numbers, again, we need a specific hardware and components and circuit to do the addition. But if we can actually convert this subtraction to addition, and instead of subtracting two numbers, add these two numbers, we only do one operation and it increases the efficiency of our machines. Because of that, we've got to know how to convert and how to make negative numbers. Another example, 5 minus 2, it's equal with 5 plus minus 2. So as you see, what we've got to do, we've got to make 2 negative and then add the numbers. So we have a couple of techniques for doing this operation, for making negative numbers. We discussed a couple of them today. So the first one is sine magnitude. Sine magnitude. So what is sine magnitude? Look guys, in sine magnitude, as you see from the name, we've got sine and we've got magnitude. So we have 8 bits. In this 8-bit, the leftmost bit is called MSB, and it's used, or most significant bit, we use that for the sign of the number. The rest, 7-bit, we use for magnitude. This is magnitude. So the first bit, sine, and the rest magnitude. How? What do you mean by sine? Look guys, in MSB, if you have 0, it shows and it represents a positive number. It's positive number, not plus 1. It's a positive number, and if we have 1, it represents negative number. What about the rest? Similar to what we discussed so far for the binary numbers. So let me give you an example. For example, I want to make plus 5 and minus 5 by sine magnitude technique. Look guys, with this technique. So this is plus. It means that the MSB should be 0. This is minus, the MSB should be 1. So by this 1 and 0, 1, 2, 3, 4, 5, 6, 7, 8. By this 0 and 1, we can easily understand which one is negative, which one is positive. This is negative, this is positive. What is 5 in terms of the magnitude for binary numbers? I'm sure you know better than me now that 5 is 101. If you're not sure, look guys, if you remember, here is 1, 2, 4, 8, 16, 32, 64. So 4 plus 1 is 5. So we've got 1, 1, 1, 4. The rest is 0. What about for minus 5? Same thing in terms of the magnitude, but the MSB is 1. So as you see here, 0, 0, 0, 0, 0, 1, 0, 1, it shows plus 5, and 1, 0, 0, 0, 0, 1, 0, 1, it shows minus 5. So the MSB plays a very important role in terms of the sign of these two numbers. And here, as you see, the magnitudes are the same. Here is for magnitude, here is for sine. Another quick example. If I want to give another example, let's talk about this. 1 0 0 0 0 1 0 1 5 6 7 8. Actually, we had similar to this. Let's make this 1 1 and here 0. And 0 0 1 0 1 0 0 1. What are these numbers? We are using sine magnitude. Look, guys, immediately, if I know that that's a sine magnitude technique, I know that that's a negative number, and I know that this is the positive number. So far, I don't need to look at these two bits anymore. Now, these magnitudes are important. So, what is the first number? Here is 1, here is 4, and here is 8. 8, this is 13. So, this one shows minus 13. What about this? Here is 1, here is 8, and here is 16, and here is 32. 32 plus 8, 40, this is plus 41. So as you see, guys, the first bit shows the sign, the rest shows the magnitude. That's the first technique that we use in binary for negative numbers. What is the other two techniques? The first one, which is very important, is called one's complement. One's complement. It's an important technique. What's that? Look, guys, in one's complement, what we do, by flipping the bits, I mean 0 to 1 and 1 to 0, we can make a negative number. For example, if you have 0, 0, 0, 0, 1, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. If you want to make negative of a negative number of that, you've got to flip the bits. Look, guys, 0 will be 1, 1 will be 0, 1, 0, 1, 1, 1, 1. This is the ones complement of the other number. So ones complement, what we do, we flip the bits. So let me give an example. For example, I want to subtract two numbers, 1, 1, 0 minus 0, 1, 1. I want to subtract these two numbers. So look, guys, as I said at the beginning, what we need to do, we need to make the second number negative. Literally what we do is this, we add the numbers, but make the second one negative. So how to make this one negative? So as I just said, for making the second number negative, you need to flip the bits. 1, 0, 0. Flip the bits, very easy. So the first thing that you need to do, 1, flip the bits. For which one? For the second number, because we want to make that number negative. So second one, I just did that. So the first one, which is this one, I flip the second one. Instead of 0, 1, 1, I've got to write 1, 0, 0. 2, add the numbers, because we want to convert this subtraction. Oops, I want to make this subtraction to addition. The whole idea is this. Now add them, 0, 0, 0. We learned that last week. 1, 0, 1. 1, 1, 0, and I have carry 1. Look, guys, in one's complement, for subtracting two numbers, what we do, if we have carry, you've got to add it to the number that you get. It means that you've got to add this number here again. What happens? 1 plus 0, 1. 1 plus 0, 1. 0 plus 0. Look, guys, interesting. What is this number in decimal? This is 4 plus 2, 6. What is this number? 1 plus 1, 1 plus 2 is 3. So the subtraction of 6 minus 3 is 3. Here is 3. It worked. Another example. Another example. Look, guys, for example, 12 minus 5. First of all, go and find 12. 12 is 1, 1, 0, 0. 4 plus 8. 5 is what? 1, 0, 1, 0. You've got to have the same number of the bits. You cannot have 3 bits here, 4 bits here. No, you've got to have the same number of the bits. So what I said, first of all, flip the second number. 1, 0, 1, 0. First, flip. 2, add them. Okay, 1, 1, 0, 0 plus this one, the flipped version, 1's complement. Add them. 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, I have carry. Carry, if you have carry, add it. So it means that I've got to add it by 1 because I had this carry here. So if you have carry, add them. 1, 0, 1, 1, 1, 1, 0, 1, and 0. Good. What is this number? What is this subtraction? So 12 minus 5 is 7. What is this? 1, 2, 4. If you add them, you get 7. So 12 minus 5 is 7. Good. So plenty of exercises are on the worksheet, and please do all of them. So the other technique that we use. What is the other technique? It's called 2's complement. 2's complement. What is 2's complement? So as you see, we had the first one, sine magnitude, then 1's complement, 2's complement. 2's complement is the best approach that we should use. And this is one of the questions that you need to think at the end, that why it's better to use 2's complement rather than 1's complement. But what happens in 2's complement? If you have a number, for example, 0, 1, 1, 0, if you want to make it negative in 2's complement, you need to flip the bits. Flip bits. You've got to flip the bits, okay? First of all, 1, 0, 0, 1. Then you've got to add it by 1. So these are the two things to make 2's complement. So flip the bits, add it by 1 here. If you remember, in 1's complement, we added carry at the end, but here we add 1 when you flip the bits. 1, 0, 1, 1, 0, carry 1. 1, 0, 1, 0, and 1. This is the 2's complement of this number. So again, if I have this number, for example, 1, 1, 0, 0. If I want to, oh, they are the same thing. So let me make it like this. 2's complement, flip the bits, add it by 1. It gives you the 2's complement. So as you see here, this is the 2's complement of the original one. So how to subtract two numbers? For example, if I want to subtract 17 minus 6. 17, what is 17? Is 16 and 1. 1, 2, 4, 8, 16. 16 plus 1 is 17. Minus 6 is 4 and 2. 5 bits here, I should have 5 bits. 5, 5. So how we can do that do this subtraction in 2's complement? First of all, for make 2's complement, it means that you've got to flip the bits. So flip the bits. 1, 1, 0, 0, 1. 2, add 1. You've got to add 1 here. Add 1. 1 plus 1, 0. We've got carry 1. 1 plus 1, 1 plus 0, 1, 0, 1, 1. So this is our 2's complement. Now you've got to add numbers. You've got to add numbers. We've got 1, 0, 0, 0, 1 plus 1, 1, 0, 1, 0. Add these two numbers. 1 plus 0, 1. Don't carry, you don't have carry. 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0. We've got carry 1. Look, guys, that's the difference between 1's and 2's complement. In 2's complement, if you have carry, you've got to discard that. You've got to discard that. Easy. We don't need that bit anymore. We don't need that carry. So this is the final answer. Again, 2's complement. Flip the bits, add it by 1. This is your 2's complement. This is your 2's complement. Then add it by the original number. If you have carry at the end, you discard. Look, guys, 17 minus 6 is 11. Is that 11? This is 1, 2, 4, 8. 8 plus 3 is 11. I'll give you another example and wrap up this session. For example, 12 minus 9. What is 12? Is 1, 1, 0, 0. What is 9? Is 1, 2, 4, 8. This is 1, 0, 0, 1. First step, make 2's complement. Flip the bits. 0, 1, 1, 0. Add by 1. Add by 1 to make 2's complement. 1, 1, 1, 0. Add numbers now. 1, 1, the original number, and this one. 1, 0, 0, plus 0, 1, 1, 1. Add these two numbers. 1 plus 1, 1. 0, 1 plus 0 is 1. 1 plus 0, 1, 1, 0. Carry 1. 1 plus 1 plus 0, 0. Carry 1. 2's complement. Discard the carry. This is your answer. 9 minus 12 is 3. This is 1 and 2, which is 3, which is. So guys, I hope that you learned this topic well. Please do all the exercises. And if you have any question, please let me know. Thank you.